which is often asked in the exam for 2 marks. Pascal's Law. A brake system for automobiles, sudden stoppage of a vehicle, compressibility, called hydraulic brakes. The pressure is transformed throughout the liquid. Eureka! Excitation! I found it out. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. My yesterday's session, I started my discussion on the properties of fluids. And we told a fluid is a substance that can flow. Liquids and gases are treated to be fluids. Liquids have their own size but not shape. A gas doesn't have its own size nor the shape, but it acquires that of the container. We spoke about fluid thrust, fluid pressure, units of pressure, and so on. Continuing my discussion today, we will study a very important law called as Pascal's Law, which is often asked in the exam for 2 marks. Pascal's Law. Dear students, at the later half of yesterday's session, we derived an expression for liquid pressure and we wrote liquid pressure P is rho GH, the pressure exerted by a liquid on the surface in contact with it is rho GH. And pertaining to these concepts, we study something called Pascal's Law. Now, what does Pascal's Law say? It says, consider a container which is filled with the liquid. Some container which is filled with a liquid. And he says, disturb any region of this fluid. There is a container which is containing some fluid, and he says disturb, apply some pressure to any region of this fluid. Then according to Pascal's law, this disturbance is carried throughout the liquid. The pressure is transformed throughout the liquid without being diminished in magnitude. The magnitude of the pressure, the so-called disturbance, is equally propagated throughout the fluid. And this is what Pascal's law states. It states that if some region or some point of an fluid is disturbed, then the disturbance is carried throughout the fluid without being diminished in magnitude. The magnitude of the disturbance propagated throughout the fluid remains the same. Now, coming to the applications of Pascal's law, again, a 2-mark question asked. The first application is hydraulic press. You should have heard the name hydraulic press. What is it? A small force applied on a column of liquid is made available as a larger force acting on another column of liquid. Two columns of liquid are connected to each other. A small force is exerted to the first column, which rages out, comes out as a larger force acting on this second column, and that is what is called hydraulic press. Hydraulic brakes, very familiar. Hydraulic brakes, which works on the principle of Pascal's law. A brake system for automobiles, sudden stoppage of a vehicle, compressibility, called hydraulic brakes. And we have hydraulic lifts. It is used to lift heavy bodies like automobiles. And you see dentist chairs, they also work on the principle of hydraulic lifts. So Pascal's law, students, has got a wide range of applicability, where we saw it is used in hydraulic press, hydraulic brakes, hydraulic lifts, and so on. And this is what is Pascal's law applied to a fluid. Now, Archimedes Principle, which is very famously called the principle of Eureka. Not the name of a female. Eureka, excitation, I found it out. Now, what does this Archimedes Principle state? Whenever a body is immersed completely or partially in a fluid at rest, exactly like taking bath inside a water tub. So when a body is immersed completely or partially in a fluid at rest, it experiences upward thrust. The body will experience upward force due to that water, fluid. What is that upward force called? Upward thrust. equal to the weight of the fluid displaced. So when you immerse a body partially or completely inside water which is at rest, naturally some amount of fluid comes out. Why? Because there is an upward thrust acting on the body which is equal to its weight. So, equal to the weight of the fluid displaced, the magnitude of that upward thrust, the magnitude of that upward force acting on the body is equal to the weight of the fluid that is displaced. So beautifully we understand, whenever a body is immersed, you are immersing the body completely or partially inside a fluid at rest. Then what is the magnitude of the upward thrust acting on it, upward force acting on it? It is equal to the weight of the fluid displaced. How much of fluid is come out? The upward thrust is equal to the weight. And this is what is called Archimedes Principle, which actually helps us to define a phenomenon called flotation, floating bodies. Now, what is flotation? See, we observe certain bodies in one fluid float but sink in another. Bodies float in certain liquids while sink in another liquid. For example, ice cube, beautiful example. Ice cube floats in water but sinks in alcohol. You drop a cube of ice in alcohol, it sinks. While on water, it floats. What are these floating conditions? Why bodies in certain liquids float while in certain liquids sink? And the conditions are here. The force of buoyancy. Buoyancy is nothing but flotation. Technically we call buoyancy. The force of buoyancy acting upwards. See, we had P is rho GH. So now we have F is V rho G, where V is the volume of the body. Therefore, we say, if rho is greater than rho dash, the object will sink. And if rho is less than rho dash, the object accelerates upwards. It will accelerate upwards and the body will continue to rise until the buoyancy becomes equal to its weight, and then the body starts to float. Therefore, we say such a body is called floating body. When do you say a body floats? density should be less than rho dash. Here there is an acceleration upwards and the body starts to float. Therefore, if we try to understand the conditions for equilibrium of floating bodies, when a body floats freely in a liquid, these are conditions for equilibrium of floating bodies. We say, when a body floats freely in a liquid, the weight of the body is equal to the weight of the liquid displaced. Archimedes Principle hai. If the body floats freely over a liquid, then the weight of the body should be equal to the weight of the liquid displaced. How much of liquid is displaced? The weight of that liquid displaced is equal to the weight of the body. The center of buoyancy, andre, the center of the gravity of the displaced liquid is above the center of gravity of the body. When flotation happens, the center of gravity, the equilibrium position of the displaced liquid, depending upon the nature of the liquid, is either above or below the center of gravity. And these are the conditions for the equilibrium. So basically understand, when the density of the liquid is greater than the density of the body, flotation happens. And the conditions for equilibrium is mentioned here. So what did we learn in today's class? Pascal's law. If a liquid is disturbed at any region of its position, the disturbance is carried throughout without being diminished in magnitude. Applications: hydraulic lifts, hydraulic brakes, hydraulic press. What is Archimedes Principle? A body, if immersed completely or partially in a liquid, the magnitude of upward thrust is equal to weight of the fluid displaced. Depending on this condition, the body floats or sinks, and this is the condition for the equilibrium of floating bodies. So next, students, we come up with Bernoulli's principle and its applications. Until then, go through this session. They are all easy chapters to understand, easy weightage chapters. We'll meet in the next session. Until then, have a nice time. Thank you.